So cap and trade has actually been used in the real world. Acid rain is caused by sulphur emissions, principally from power plants that burn coal. And in the past, most of this sulphur ended up in the atmosphere. And when it reacts with oxygen to form sulphur dioxide and mixes with water, it creates an acid. And this acid is bad for plant life and for fish in lakes and waterways. So there is a clear negative externality from power production in this case. There's a regional pollutant that's added to the atmosphere that damages the environment. So you could mandate an emission rate. You could say we're going to lower that emission rate. There's a law, you must reduce by a certain amount. So that's a possible policy solution. But it was widely recognised in the industry to be very expensive because some firms would find it very difficult to make meaningful cuts in their sulphur dioxide emissions. Also, it doesn't incentivise individual plants to cut their sulphur dioxide emissions by more than the minimum, or to develop technologies that reduce the amount of sulphur dioxide emission that they could then perhaps sell or share with other companies. So, in 1990, the Clean Air Act mandated that overall sulphur emissions had to be halved. But it let individual companies decide how to do it. And what's more, if you cut your sulphur emissions as an individual company by more than that 50% limit, then you had the right to sell that right to pollute, the cap and trade, to other firms. This meant that the most efficient firms had the incentive to keep cutting their emissions. This policy appeared to work very well. Within 10 years, sulphur emissions had been cut faster than it was predicted was possible, and it was also much cheaper. In fact, the best estimates was that it cost about a quarter to make the cuts that would have been required if it had have just been a simple mandated cap. By 2000, scientists were already recording lower sulphur levels in water bodies. As we can see in this graph, there was a big difference in the amount of sulphate deposited by precipitation between when the new law was brought in 1990 and just 12 years later in 2002. In the United States, air quality is better than it's been in decades, and that's a combination of these sorts of market incentive plans and also because of other mandated command and control legislation that lowers the ambient standards of noxious pollutants. Sulphur dioxide is actually a good example. Over the last few decades, it's continually declined as a percentage of the local atmosphere in American cities. In one of the earlier lectures, I used driving a car as an example of a negative externality because it produces carbon dioxide, which results in climate change. Have you ever wondered how much damage you're responsible for because you produce carbon dioxide? Well, obviously, the amount of damage that you're doing, your social cost, depends on how much carbon dioxide you emit. If you're an average Australian, Canadian or American, it's almost 20 tonnes of carbon dioxide per year. If you're highly virtuous and live in one of those countries, or if you're an average resident of Europe or Japan, you'd be emitting more like 10 tonnes of carbon dioxide per year. And if you're from another country, such as China or Mexico, you might emit around 5 tonnes of carbon dioxide per year, and that's actually about the world average. It's about 5 tonnes of carbon dioxide per person per year. If you come from India or Africa, the average person in your nation is likely to emit less than 2 tonnes of carbon dioxide per person per year. You can see your country on this map here, so you can get a sense of what the average per resident for your country is. To put a tonne of carbon dioxide in perspective, if you burn a litre of petrol, that creates about 2.5 kilograms of carbon dioxide. Equivalently, burning a gallon of gasoline or a gallon of petrol creates about 10 kilograms, or about 1% of a tonne. So you emit about 1% of a tonne every time you burn a gallon of gas. Economists have tried to calculate how much damage each of those tonnes is doing to the environment. This is that social cost that we examined. Or you might describe it as the negative externality. Sometimes this is reported in tonnes of carbon, not in tonnes of carbon dioxide. So we have to be a little bit careful when we see a number because there's actually a pretty big difference. Each tonne of combusted carbon produces about 4 tonnes of carbon dioxide. So if you're emitting 20 tonnes of carbon dioxide, you're emitting around 5 tonnes of carbon. So if we talk about a cost per unit of tonne of carbon emitted, that's quite different than per tonne of carbon dioxide. So I'll try and be careful when I discuss the numbers. More than 100 estimates of the social cost of carbon emissions have been attempted, and they have a pretty big range. The estimates run in US dollars from between minus $10, so that is, in other words, there's a net benefit from emitting carbon dioxide, to $350. So there's a net cost of every tonne of emission costs $350 in those negative externalities, those social costs. Of all the peer-reviewed estimates, that's one that have gone through the scientific process, the average is around 43 US dollars per tonne of carbon emitted. That's the value used in the International Panel on Climate Change report. But they also note there's a big variance, and so the real social cost could be much higher than that, or it could also be lower. If we use this average value of $43 per tonne of carbon, then that comes out to be about $12 of social cost per tonne of carbon dioxide emitted into the atmosphere. So the average American, therefore, under that calculation, has a negative externality of 20 tonnes times $12 per tonne, or around $240 per year. The average Chinese person, on the other hand, who emits on average 5 tonnes per year, it's 5 times 12, or about $60 of negative externality. Now remember, it's possible that the net negative externality is much higher than this. Those who see tipping points in the climate suggest that the actual value should be closer to that $350. So that's almost 10 times as much. So it could be that instead of it being $250-ish for the average American in that net social cost, which is currently not being paid, it should be more like $2,000, which obviously is a lot. So one way to take into account this social cost, as we've seen, is to add a tax. And this has been known as a so-called carbon tax. Depending on your estimate for what that social cost is, it would range from nothing to about $1 per gallon of gasoline, or 25 US cents per litre, with the average estimate suggesting around 10 to 15 cents per gallon of gasoline. That's not that much compared to the average pump prices, and actually would be overshadowed by the recent changes we've seen in the prices of gas. Still, it's worth something. If you add up all the people around the world, 7 billion, using on average 5 tonnes of carbon dioxide emitted per year, then you get a value of around $350 billion per year in social cost, which is not accounted for. And this doesn't account for all the non-monetary effects. I know that a lot of you will be thinking, well, what about the natural systems that don't have a financial stake? A lot of these aren't included in the calculation, so the real social cost is even higher. So why don't we do things to deal with that? Well, we have different options. One is we could do a cap and trade. This has actually been done in Europe for a number of years. Unfortunately, too many carbon credits were allocated. Too many firms had too much right to pollute. As a consequence, the price of emitting a tonne of carbon crashed in the cap and trade scheme from around $20 per tonne of carbon, or around $5 per tonne of carbon dioxide, to under $5 per tonne of carbon, or around $1 per tonne of carbon dioxide. And clearly, this is much lower than the consensus estimate of the social cost of emitting a tonne of carbon dioxide. This points to a policy failure. It could be that government planners didn't understand the social or economic issues well enough. In other words, they didn't predict the recession. They don't have a very good understanding of the social system. Or it could be that this was more of a failure of competence, that the governments had to give away too many free rights to pollute to get the legislation passed. And this might be known as a political economy problem. Another approach is a carbon tax. This would be an example of a Pigovian tax. A Pigovian tax is applied to a market activity that generates a negative externality. The idea of a Pigovian tax is that it corrects a market failure and brings the market system into line where the result is the most efficient when we account for the social cost. Generally, economists like this approach, as both the polluter pays and we get an efficient outcome. But remember, we have to know how much damage that pollutant is doing. Note the huge range in the predicted cost of carbon, for example. This is not easy to do in many cases. In practice, the measurement might be too hard. And what if part of the cost is something that can't really be measured? So, for example, we miss the cold winters of our youths. Now, that might not have a real financial value to it that can be easily expressed, but nevertheless, that could be a loss. Also, the familiar political problems apply to Pigovian tax approaches as well. The government is limited in its capacity and may be overly swayed by lobbyists, by corruption, or by the irrational preferences of the lawmakers or the voters. So in the case of carbon pollution, a Pigovian tax would take into account the social costs of climate change if it could be arranged. Some countries have actually brought in carbon taxes. Generally, like most taxes, they're unpopular. So, for example, if we remember that the social cost of a tonne of carbon dioxide is about $12, then we can say that a New Zealand tax of around $15 New Zealand, which is around $12 United States, would be a reasonable value. But this tax was actually abandoned. It was not politically popular. Australia has a carbon tax of $23 Australian per tonne. That's about $25 US per tonne, so that's in the ballpark of what we would expect, but it has many exceptions. Sweden also has a tax, a very high rate tax of around $140 per tonne, but they also have lots of exceptions, as do Norway, who have a tax of around $20 per tonne. It seems like having lots of exceptions is part of the price of getting a carbon tax through a legislative process. This means that these taxes are less efficient than they would otherwise be. Many countries don't have formal carbon taxes, but they still tax carbon producing activities very heavily. A good example of this would be the United Kingdom. There, the price of petrol at the pump is about 2/3 surcharges and taxes. So most of the money that you spend when you fill up your car is actually money that goes to the government. So in this case, you might say, well, we don't need a carbon tax because it's already accounted for in our other ways that we tax our systems. So it's not always as straightforward as you might think.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.